For 100 years, the U.S. Department of Energy's National Energy Technology Laboratory has been a leader in energy technology development. These advances benefit the American people, enhance our nation's energy security, and protect our natural resources. Today, NETL houses an extensive network of on-site laboratory facilities and manages more than 1,000 partnerships with industry, academia, fellow government agencies, and international research organizations. A century ago, NETL's foundation was laid with the establishment of a new federal agency, the U.S. Bureau of Mines. In 1907, a series of deadly explosions in America's coal fields drew attention to the dangerous practices of the coal mining industry. 3 years later, on May 16, 1910, Congress founded the Bureau of Mines and asked its staff to develop technologies that would protect the lives of our nation's mine workers. Bureau Director Joseph Austin Holmes quickly made history with a well-planned coal mine explosion at the Bureau's first research site, the Pittsburgh Experiment Station. As hundreds of spectators looked on, flame and smoke erupted from the mouth of the Bureau's experimental mine. This single event proved beyond doubt the highly explosive nature of coal dust, which until that day had widely been considered inert and harmless. The Bureau's initial efforts saved countless lives as the Pittsburgh Experiment Station went on to develop coal dust controls, cooler burning explosives, and techniques for minimizing spark and flame. In the decades following, the Bureau created a nationwide network of facilities focused on fossil fuels research. It established experiment stations in Morgantown, West Virginia, and Bartlesville, Oklahoma. It built field offices in Grand Forks, North Dakota, Laramie, Wyoming, and Boulder, Colorado. And it created the Northwest Electro Development Laboratory in Albany, Oregon, to investigate rare metals and develop advanced materials for a range of applications. Resource conservation and reliable energy supply were primary concerns of these research centers. Under the Synthetic Liquid Fuels Act of 1944, Pittsburgh and Morgantown investigated coal gasification and coal-to-liquids technologies. Morgantown also played a major role in commercializing fluidized bed technology. Today, this is a standard power plant mechanism in which finely powdered coal mixed with air acts like a liquid. The better mixing of fuel and air enables lower temperatures in these systems, which in turn reduces emissions and conserves fuel. NETL's participation in the development of this technology has made possible more than $6 billion in domestic sales and $3 billion overseas. The Bureau's Bartlesville station helped pioneer enhanced oil recovery. In the early days of America's oil boom, primary recovery was leaving as much as 90% of our oil supplies underground. Working with industry, Bartlesville pioneered water flooding techniques to flush larger quantities of oil out of the rock formations trapping it. Later, researchers began using chemical solutions to free petroleum from surrounding rock and microbes to thin heavy petroleum so that it could be more easily extracted. Today, enhanced oil recovery contributes more than 10% of U.S. crude oil production. With advanced techniques such as CO2 flooding, this number is expected to increase. During that time, Bartlesville also developed one of the first reservoir simulators. Referred to as the Black Oil Simulator, or BOAST, this tool is still used by students in petroleum reservoir engineering. Bartlesville published information on these technologies by organizing industry's first International Improved Oil Recovery Symposium. The symposium continues today under the auspices of the Society of Petroleum Engineers. Enhanced oil recovery and natural gas production are now standard practice, helping ensure that the United States taps its domestic energy supply to the fullest extent. From the early to mid-20th century, the Bureau of Mines' contributions to the energy industry were substantial. Substantial, too, were the applications its technologies found outside the energy arena. In Albany, renowned metallurgist William Kroll and his staff made history when they produced the first pure, malleable samples of zirconium, a valuable rare metal. On the heels of this remarkable achievement, Albany supplied the zirconium rods needed to power the USS Nautilus, the U.S. Navy's first nuclear-propelled submarine. Because of its expertise in managing coal mine gases, the Pittsburgh station helped design the ventilation system for the Holland Tunnel, linking New York City and New Jersey. In Bartlesville, Bureau scientists launched a thermodynamics research program that gained worldwide recognition. The program's work in hydrocarbons enabled the development of synthetic rubber, a material vital to the Allied military efforts during World War II. Bartlesville scientists also designed an artificial smog chamber, and with it, conducted trailblazing research on the causes of air pollution in American cities. Pittsburgh, Albany, and Morgantown lent their expertise to U.S. space program studies of rocket propellants, lunar samples, and the capacity for metals to endure the extreme conditions of outer space. During the 1950s and 60s, energy supply was abundant and inexpensive. In the early 1970s, however, the United States suffered the most severe energy crisis in its history. Prices soared and imports became scarce. In response, the federal government expanded and restructured its support for energy research. The Bartlesville, Morgantown, and Pittsburgh experiment stations were rechristened Energy Technology Centers under the newly formed Energy Research and Development Administration. 2 years later, the centers were reassigned to the U.S. Department of Energy when it was established in 1977. Throughout the decade, the expansion of domestic energy supplies was the center's critical mission. Pittsburgh, Morgantown, and Bartlesville began to pursue unconventional natural gas resources. Engineers tapped tight gas formations, which trap natural gas in dense, ancient rock. They also introduced coal bed methane as a new resource. Today, this one-time waste fuel plays a regular part in America's energy portfolio, accounting for approximately 10% of U.S. natural gas production. To access unconventional resources, oil and natural gas producers needed unconventional drilling technologies. In answer, researchers brought directional drilling into play. The culmination of this research was horizontal drilling, which has since been enhanced by the development of coiled tubing drilling rigs and computer-controlled or smart drilling. As the 1980s dawned and oil prices fell, concerns over energy supply eased. However, the impact of America's fossil fuel consumption on our air, land, and waterways were starkly evident. For many, two words summed up the relationship between coal and the environment: acid rain. To neutralize this threat, the Pittsburgh and Morgantown Energy Technology Centers administered DOE's Clean Coal Technology Demonstration Program. Through the program, NETL and its partners introduced cleaner, more efficient coal use technologies to market. Today, 75% of our nation's coal-fired power plants use pollution control devices that were in some manner supported by the program during their development. For example, scrubbers, which remove sulfur dioxide, are widely deployed throughout the industry, as are advanced burners and selective catalytic reduction systems, both of which reduce emissions of nitrogen oxides. And the acid rain threat has nearly been eliminated. Nitrogen oxide and sulfur dioxide emissions have dropped precipitously despite a near tripling of coal-based power generation. The Clean Coal Technology Program also promoted integrated gasification combined cycle, or IGCC, power plants, which combine three of the Technology Center's research specialties: coal gasification, gas purification, and advanced turbine engines. IGCC power plants are the world's cleanest coal-fired power plants. With technologies continually under development, they can achieve near zero emissions with minimal increase in cost of electricity to consumers. With support from the Morgantown and Pittsburgh Energy Technology Centers, two IGCC plants, the Wabash River Power Station in Indiana and Tampa Electric Company's Polk Power Station in Florida, came online in the mid-1990s. Both are still in operation today. Throughout the 1980s and into the 1990s, the Albany Minerals and Materials Lab, renamed the Albany Research Center, remained with the Bureau of Mines. Its scientists continued to make breakthroughs with rare metals, most notably titanium, and they developed a range of materials that could endure harsh environments. Albany's materials expertise would eventually enhance the power systems research being conducted by Pittsburgh and Morgantown. For nearly 9 decades, researchers in Bartlesville, Morgantown, and Pittsburgh had been developing technologies to solve our country's diverse energy challenges. Finally, at the turn of the new millennium, the multiple strands of what comprised DOE's core fossil energy program came together. In 1996, the Pittsburgh and Morgantown centers merged to form the Federal Energy Technology Center, known as FETC. 3 years later, on December 10, 1999, DOE elevated FETC to the rank of National Laboratory, now to be known as the National Energy Technology Laboratory, or NETL. Former Bartlesville operations, now located in Tulsa, Oklahoma, and called the National Petroleum Technology Office, joined NETL in 2000 and moved to Sugar Land, Texas in 2009. In 2001, DOE established its Arctic Energy Office, located in Fairbanks, Alaska, and assigned this energy center to NETL. And with the 2005 edition of the Albany Research Center, which was transferred to DOE upon the Bureau of Mines closure in 1996, our laboratory was complete. Today, NETL's mission is twofold: promote advanced energy systems that ensure reliable supply and protect the environment. We are an international leader in carbon capture and storage to mitigate climate change. Our carbon management research began in the mid-1990s and has grown into a multifaceted, multi-million-dollar research, development, and demonstration program. We are forging breakthroughs in materials science, developing metals, ceramics, coatings, and sensors that withstand the highly corrosive environments of high-temperature, high-pressure power systems. We are developing advanced drilling and subsurface imaging technologies. These tools will enable economic and environmentally acceptable access to our nation's vast, unconventional, and ultra-deep natural gas and oil resources. Our investigations of methane hydrates and new energy feedstocks such as blends of fossil fuels and biomass are burgeoning programs. We are closely involved with the modernization of America's electric grid. Our energy systems analysis and planning inform policy and regulation and guide our program development. And our research in vehicle technologies, building efficiencies, fuel cells, hydrogen power, and other ultra-low emissions power systems takes us beyond the realm of fossil fuels. Energy is paramount to human welfare. It allows us to feed our families, access clean water, and operate our hospitals, schools, businesses, and industries. 100 years ago, the Bureau of Mines was founded to improve our nation's coal mining practices, bringing science to bear on the problems of resource recovery and mine safety. The organizational construct of U.S. energy research has evolved, but the fundamental mission remains: protect our citizenry, our resources, and our environment. NETL continues to grow as current energy challenges become more complex. Power generation means more than just fossil fuels, and new issues confront our nation and our world. By understanding the energy landscape and the social and economic impacts of advanced power systems, America can enjoy clean, affordable, and secure energy for generations to come. NETL is helping to provide this understanding and will continue to develop energy solutions that address the needs of the nation over the next 100 years.